Hi, everyone. We are working on Module 4, and this is the introduction lecture for Git flow. So a pop quiz. What Git flows have you used in the past? So if you're new to software development, you might not have worked with many Git flow or Git workflows, or maybe none at all. The idea in Git is that you'll have a main branch, sometimes called a master branch, and a develop branch. And doing development where you're doing developing software on the development branch, and then you release the software to the master branch or the main branch. That's a common workflow. It works great for single individual people. It works great for small groups of developers. And so that's an example of a workflow. Another example of a workflow is Git flow, and so that's what this introduction is talking about. So again, we're going to try to do the what, why, and when of Git flow. So what is Git flow? Git flow is a set of Git extensions that provides high-level operations that implements Vincent Dreisen's branching model. And so Vincent Dreisen created this workflow in 2010. Git flow encapsulates several other Git commands into a series of commands to save time and complexity in managing Git branches and releasing software. It assigns very specific roles to different branches and defines how when they're used. So this picture, don't let it be intimidating. It's trying to give you an overview of what's going on with Git flow. So this is continuing what is Git flow. So Git flow simplifies a series of Git commands into one command, and this table here is offering you kind of an example of that. So there's this concept of releasing a hotfix on software. Say that you've released software and you find there's a bug in it, and you've released it to your customer and it's not working. And so it's a simple fix typically, and so you'll do what's called a hotfix, a real quick fix. And so the command to do that or accomplish that in Git flow land is git flow hotfix start, version 1.2.1, and commit. The same command in Git land is still a one-liner. It's a little bit longer. It's git checkout -b hotfix /1.2.1, and then a commit message. The next command is a better example of how it condenses or simplifies the commands you're typing. So when you're done with your hotfix, you would type in a command something like git flow hotfix finish 1.2.1. Well, to accomplish that same action in Git land, you have 6 commands there that you have to type to do this. So it's saving you time, saving you steps that you have to do if you're doing this with Git. The next example here, git flow feature finish my feature. So we're using git flow to finish a feature called my feature. To do this same thing in Git land, it's a series of 3 commands. So again, it's a time saver. There's more examples at that URL there. All right, so why do we use Git flow? The Git flow workflow allows for parallel development of software while avoiding conflicting code. This graphic kind of examples this. So the center icon of origin represents the origin of the software that's up on GitHub or Bitbucket. And you have Alice, David, Bob, and Claire that are all pulling from this origin repository to their local laptops, and they're doing various types of features and development on it. And the communication is bi-directional, basically. And so this is trying to manage everyone's development of the software and keeping them from conflicting or overriding each other's work. So Git flow allows for collaboration on projects and encourages code review and allows for emerging hotfixes of software. So when should you use Git flow? Every sprint cycle to make a release. So there's a larger concept in software development called Agile and Scrum. And so the terminology is you have a sprint, and you will sprint in a certain time frame. So one team might choose to make their sprints 2 weeks long. Another team might choose to make their sprints 3 weeks long. And so what they're doing is they're planning work that it can be accomplished and finished that is doable within 3 weeks or 2 weeks, whatever your sprint cycle is. So at the end of the sprint cycle, you should have a deliverable feature or part of a software that you can release to a customer. So that's the concepts what I'm saying when I say every sprint cycle to make a release. That's the idea what I mean there. And so you should also use GitFlow during the week, every week that you're developing software. And then additionally, each time a new feature or enhancement is created for one of our projects or of software. So how do we use GitFlow? So this is a different graphic that represents the same thing that we saw earlier, but I think it's a little bit cleaner. So fundamentally, we need to understand that GitFlow has concepts of historical branches, which are the master and develop branch. Sometimes master can be known as main. They're used to record the history of the project, and they contain the ongoing development and releases of the software. To this idea of temporary branches, which are the feature release and hotfix branch, the maintenance branch. So features are placed to develop multiple features at the same time. And then releases they start a release cycle of software. A release branch doesn't live long. GitFlow release start a release version of software, and then you make a couple adjustments to what's called a change log, and then you release it. So it might take 10 minutes, and then your release is done, or 15, an hour to do your release. They typically don't last long. Whereas features, you can create a feature branch. It's temporary in nature, but it might go on for weeks, months, a day. So that's the concept there. And then hot fixes are typically short-lived. You'll use a hotfix to quickly patch production releases of software. So this video plays.
GitHub Desktop. So you have two branches that are permanent. There is the master branch and the develop branch. And you start off with your version 1 in master, and then push that down to development. And basically the developers are always working off of the develop branch. The only thing on the master branch are the releases that are in production at any point in time. So let's say a developer wants to work on a feature, they're going to clone it from develop, work on it, and then push it up to develop. And when it's time to make a release, the release branch is going to get what's currently at the head of develop. And if any changes need to be made, like some documentation added, there'll be some more commits. And then when it's ready to go to production, it will be pushed to master and tagged with whatever version it is, and also pushed to develop in case there were changes during that release process. Now, when there's the situation of a hotfix, it will be cloned from master. Whatever commits need to happen, whatever needs to get changed will take place. And then it will be pushed up to master and also pushed to develop, so that the developers that are working on features will have that code that was made for the hotfix. So you can see they would just pull off of the head of develop and then work on the feature and then check it back in.
So that is another way of explaining some of the concepts I've been going over with GitFlow. I think that presenter does a really great job of explaining how the data kind of flows between branches. So how do we get started with GitFlow? So say that you have a Git repository. If you want to use GitFlow in that repository, you have to first go to the repository folder and then type in GitFlow init. And so this command modifies the repository's .gitconfig file to create the develop, feature, hotfix, and release branch concepts, so that Git is aware that you're using GitFlow and using those branches. Say that you want to start and finish a feature. The commands look like this. To begin working on a new feature for software, you would type in git flow feature start, and then give the feature a name. The feature might be new button behavior for the drop-down menu on a website. So you'd git flow feature start, and then button feature as the name. So then you name the feature with a brief summary of the intent of the new feature. I was just kind of alluding to that. So add function, adjust if-then logic, create rules engine, fix form name. And then once the feature is created, adjusted, or you've or fixed, you would type git flow feature finish, and then that name. You have to use the same name for the feature you're closing, because you could have multiple features going. So if you're finished working on the add function feature, then you would specify the same name to close it. And so this merges the work performed on that feature back into your develop branch, and then you're ready to do a pull request and GitHub or Bitbucket or Bitbucket to start a review process of that software. So once the feature has been developed, it is time to review the code. Code review is done by creating a pull request from the develop branch of your repository to the develop branch of a central repository on GitHub or Bitbucket or GitLab. A code moderator is the person that reviews all pull requests and reviews the code to be added and accepts or rejects the changes to the software. And they might not necessarily, outright reject everything you've done. They might just say, hey, this line of code doesn't look right. Your syntax is not correct, and it's not working on my computer. Please go back and review this section, and you can go and work in that pull request to make your adjustments and then go for another review. So then the next idea is that once the code review is done, it's time to release it. So say this is the end of your work cycle or end of your sprint, and your develop branch has acquired enough features or enough corpus to justify going to a new version number. So to start that, you would do git flow release start and then give it the version number. So if you have version 1.0 released, you would type in the next version of 1 or 2.0. And so then you can take commit messages from the previous features and add them to the change log of the software so that someone knows what was changed in the release. And then to complete the release, you would type git flow release finish, and then that version number that you specified earlier, 2.0 is the example. So say, despite our best efforts of everyone involved in software development, from time to time an unintentional bug can be introduced in the software that needs to be fixed quickly. A hotfix is a fast way to quickly path production releases of software. So you start a hotfix by typing git flow hotfix start and then the version number. And so if we had just released 2.0, a hotfix version would be like 2.1 or 2.0.1. Then you fix the trouble code in the software, and then you complete the hotfix by git flow hotfix and then the version number. So there's a kind of like I talked about with command line, there's some extra concepts thinking about software, and it's appropriate to talk about semantic versioning in this. So semantic versioning is a set of rules and requirements that dictate how version numbers are assigned and incremented for software. So software versioning that follows semantic versioning uses a format of x.y.z, or major, minor, and patch version. Or an example here, is the 5th major version, the 2nd minor iteration of the software, and the 4th patch, or 4th hotfix. Once a version of software is released, it is not modified, but it is can be released again with a new version. So once the features of the software reach a point of initial functionality, you can make an alpha version, and then a beta version, and then like a final production release. So alpha follows the versioning concept of 0.1.0. A beta version would be a 0.2.0, and a production would be, okay, we're out of beta, we have full function, or we have our initial minimum functionality of the software, we're able to release it to the customer, so we do 1.0.0. Another extra concept thinking about Git and Git flow is commit messages. You want to create insightful and descriptive commit messages. It's one of the best things you can do for others who use the repository. It's less It lets people quickly understand changes without having to fully read the code. The normal Git rule of using the first line to provide a short 50 to 72 character summary of the change is also very good. So you want to use imperative voice in your messages. So for example, if applied, this commit message will, and then refactor a submission, a subsystem X for readability, or if applied, this commit message will update getting started documentation. Or you might say a different way. So the idea of you saying the words, if applied, this commit will, or saying the words, with this commit, I will, blah, merge pull request 1, 2, 3. You're trying to get yourself into the imperative voice. It's a tool, a mind tool to get you to say the phrase, with this commit, I will, and then what you actually type on the command line would be the statement merge pull request or update, getting started documentation. Just trying to, it's a shortcut to try to get you into the imperative voice. Notice how it doesn't work for other non-imperative forms. So if applied, this commit will, fix the bug with Y, and then more fixes for broken stuff, or sweet new API methods. You don't want to use past tense like I fixed this. You want to use the imperative voice and don't use past tense. You like you fixed a bug, that would be inappropriate. And then you want the command to actually mean something. So more fixes for broken stuff doesn't really tell the next programmer what's going on, in that commit. You don't know what's really going on. So you want it to be short and sweet and to the point. So let's go over some GitFlow scenarios. Scenario 1 is going to cover 2 features at the same time. So we have someone named Ruchi and Mohan who are working on the Alzheimer's disease research project and help maintain the algorithmic code to diagnose a patient's demented state. So sounds like some awesome software. Ruchi forks the algorithmic code repository and starts the feature to add a variable to the rules engine. And then also Mohan forks the algorithmic code repository and starts another feature to limit the range of the rules engine for an input, and starts a feature to add a rate limiter to the software. So basically, Ruchi started one feature branch to do one specific thing, and then Mohan started 2 feature branches. So Mohan finishes up his features and then merges his changes into develop branch, and then performs a pull request to the code moderator. Chris, the code moderator for the algorithmic code repository, reviews the code and accepts the pull request. Ruchi finishes her feature and creates a pull request to start a code review. So Ruchi could be coming in a week later, for example. Chris also reviews that code and accepts the code from the pull request, and then manages the merge behavior for the new features. So his screen view will be, trying to manage any conflicts if there are. And so at the end of that, we have 3 new features in this software, and Chris performs a release of the new software. Scenario 2 is where we have 1 feature and a hotfix. So Ruchi is working on the hepatitis C virus project and helps maintain the code for retrieving lab data from multiple electronic medical records across the world. So Ruchi forks the lab data code repository and starts the feature to add a new lab variable for the feature, or for the software process. Ruchi finishes her feature and creates a pull request to start a code review. Chris reviews the code and accepts the pull request. Chris performs a release of the software, but the customer alerts Chris that there's a problem where the new lab data is using the wrong unit of measure for the type of sample. So they're using microliters instead of micrograms. Actually, it can be a common data problem, actually. So Chris performs a hotfix release and pair programs with Ruchi to adjust the unit of measure for the lab. Chris closes the hotfix and then releases the software again. Final scenario here, the software release. So Chris is the maintainer of an algorithmic code repository and has managed multiple pull requests for new software features throughout a sprint or work cycle. It is the end of the sprint, and he wants to give the customer new software features to improve the doctor's tools for Alzheimer's disease research. Chris opens his terminal, and on the develop branch, he starts a GitFlow release start 2.2.0. This is the second major release of the software with a 1 minor release and no hotfix. He updates the change log to reflect all the changes made to this version of the software. And then he finalizes the release by typing git flow release finish 2.2.0. He informs the customer of the new software, and that's it. So that concludes the lecture for git flow. So thanks for listening.